Ever wondered how object-oriented programming evolved over the years? It all started back in the late 1950s, when a programming language called Simula emerged from the minds of Ole Johan Dahl and Kristen Nygaard. This language, developed in Norway, is often hailed as the first to support object-oriented programming concepts. At its core, Simula introduced the world to the concept of classes and objects. But wait, what are these exactly? In the simplest terms, a class is a blueprint for creating objects which encapsulate data and functions that manipulate that data. Objects, on the other hand, are instances of a class, each with its unique set of values. This was groundbreaking at the time. Programming was no longer just about writing procedures to perform operations on data. It was now about creating objects that not only held data, but also had behaviors associated with them. This shift in thinking brought about a new level of abstraction in programming, one that allowed programmers to model real-world scenarios more accurately and intuitively. Simula's approach to programming was revolutionary. It opened the door for programmers to think in terms of objects and their interactions, a stark shift from the procedural programming paradigm that was prevalent at the time. This new way of thinking allowed for a more natural representation of complex systems and processes, making it easier for programmers to develop and maintain software. The impact of Simula's introduction of classes and objects cannot be overstated. It paved the path for a new era in programming, one in which software could be designed and implemented in a way that mirrored the complexities and nuances of the real world. It marked the beginning of what we now know as object-oriented programming, setting the stage for the development of many of the programming languages we use today. And thus, the journey of OO programming began, leading to the creation of more influential languages. As we'll see in the upcoming scenes, this was just the dawn of a revolution that would shape the world of software development for decades to come. As the 1970s dawned, so did the era of Smalltalk. This innovative programming language, born in the labs of Xerox PARC, played a pivotal role in popularizing object-oriented programming. Smalltalk was unique, not just in its time, but even today. It was a pure object-oriented language, a term that might sound redundant now, but back then it was a radical concept. Everything in Smalltalk was an object. But Smalltalk didn't stop there. It introduced the idea of a dynamic runtime environment, a feature that allowed programs to be modified while they were running. This was a significant leap in the evolution of programming languages. However, the landscape of object-oriented programming didn't stop evolving with Smalltalk. As we moved into the 1980s, a new player entered the scene, extending the capacities of the well-established C language with object-oriented features. This was none other than C++. Designed by Bjarne Stroustrup in the late 1970s and released in the 1980s, C++ was a game-changer. It took the procedural paradigm of the C language and extended it with classes, inheritance, polymorphism, and encapsulation. With C++, developers could now create complex programs with ease. It allowed for better organization of code, making it more readable and maintainable. It also introduced concepts such as operator overloading and templates, which added a new level of flexibility to programming. Over time, C++ became a widely used language in both application and system development, further cementing the importance of object-oriented programming. So as we can see, the 70s and 80s were transformative decades in the world of object-oriented programming. They saw the advent of Smalltalk, which brought the object-oriented paradigm to the forefront, and C++, which expanded on these concepts and incorporated them into a language already widely used by developers. The 80s didn't just give us great music, they also brought us C++, a major player in the OO programming scene. Indeed, the landscape of programming was forever changed by these 2 decades, setting the stage for the further evolution of object-oriented programming. The 1990s brought a revolution in object-oriented programming. At the heart of this revolution was Java, brought to life by Sun Microsystems. Java emerged as a potent force in the programming world, with its emphasis on platform independence, security, and portability. It was designed to write once, run anywhere, a mantra that resonated with developers across the globe. Java's popularity soared, and it quickly became a highly influential language in the object-oriented paradigm. However, the 90s innovation did not stop at Java. The decade also saw the birth of the Unified Modeling Language, or UML. This standardized modeling language was developed with the aim of providing a common notation for visualizing, specifying, constructing, and documenting software systems. UML was a game changer. It allowed developers to plan and design their software in a structured manner, paving the way for more complex and robust systems. Meanwhile, another significant development was taking shape in the form of design patterns. In the mid-90s, the book Design Patterns: Elements of Reusable Object-Oriented Software was published. Authored by Eric Gamma, Richard Helm, Ralph Johnson, and John Vlissides, known collectively as the Gang of Four, the book introduced a set of widely used design patterns. These patterns, from the simple singleton to the complex observer and decorator patterns, became essential tools in a developer's toolkit. They provided solutions to common programming challenges, promoting code reuse and object-oriented design principles. From Java to UML and design patterns, the 90s was a decade of innovation in OO programming. It was a time when the principles of object-oriented programming were truly put to the test, and they passed with flying colors. The developments of this decade still resonate in today's programming world, a testament to the enduring power and relevance of the object-oriented paradigm. As we entered the new millennium, OO programming continued to evolve. The emergence of C# with the .NET framework marked a significant milestone in object-oriented programming. Born out of Microsoft's development stables, C# was released in the early 2000s. It was designed to bring object-oriented features to the Microsoft development ecosystem, providing a robust platform for application development. This language was a unique blend, drawing elements from C++, Java, and other languages. It brought together the power and flexibility of C++ with the simplicity and modern design of Java. With its strong typing, garbage collection, and interoperability with Windows, C# quickly carved a niche for itself in the world of object-oriented programming. Just as C# was making its mark, two other languages were also rising to prominence: Ruby and Python. Ruby, developed in the mid-90s, is an object-oriented scripting language that quickly gained popularity for its elegant syntax and dynamic features. It took object-oriented programming to new levels, enabling programmers to create rich and complex programs with fewer lines of code. Python, on the other hand, although not exclusively object-oriented, became a popular general-purpose language with robust support for OO programming. Known for its simplicity and readability, Python was designed to make code easy to write and understand. Its approach to object-oriented programming is slightly different from traditional languages. While it supports concepts like classes and inheritance, it also allows for a more procedural style of programming, giving developers the freedom to choose the approach that best suits their needs. These languages, each with its unique features and strengths, contributed significantly to the evolution of object-oriented programming. They brought new ideas, paradigms, and methodologies to the table, shaping the way we write and understand code today. The evolution of OO programming didn't stop with the dawn of the new millennium. It continues to adapt and grow even today. So, we've journeyed through the evolution of object-oriented programming. We've seen how it all began in the late 50s and early 60s with Simula, the pioneer that introduced us to the concept of classes and objects, setting the stage for what was to come. Then came the Smalltalk era in the 70s and 80s, taking the baton from Simula and running with it. Smalltalk introduced us to a pure object-oriented language, complete with a dynamic runtime environment, making programming a more interactive and intuitive experience. Next, we stepped into the 80s and witnessed the emergence of C++, a language that took the foundation laid by C and added a layer of object-oriented features. It introduced us to classes, inheritance, polymorphism, and encapsulation, making it a staple in application and system development. We also delved into the world of Objective-C, which combined the strengths of C with Smalltalk-style messaging and became a popular choice for macOS and iOS development. We then moved on to the 90s, where the Java revolution took place. Java brought platform independence, security, and portability to the forefront, becoming a highly influential object-oriented programming language. In the late 90s and early 2000s, we saw the introduction of C#, along with the .NET framework, which brought object-oriented features to the Microsoft development ecosystem, combining elements of C++, Java, and other languages. We also explored the development of the Unified Modeling Language, or UML, a standardized modeling language for object-oriented software design, and the introduction of design patterns, which became essential for software development. Finally, we touched on the rise of Ruby and Python in the late 90s and 2000s, two languages that brought their unique flavor to the object-oriented programming scene. Ruby with its elegant syntax and dynamic features, and Python with its simplicity and readability. And so we find ourselves here in the present, looking back at a rich legacy of continuous evolution and innovation. But remember, the story isn't over. The journey that started in the 1950s continues today, shaping the way we develop software. Who knows what the future holds for object-oriented programming? Stay tuned to find out.